So now we're back to learning GDScript from zero, and this is an open source project by gdquest.com. Let's continue where we left off over here at 2D vectors. All right. So suppose we want to increase the size of the robot when it levels up, okay? As we may recall, we do this by using the following code. So we'll have like a function, level up, we'll do scale.x plus equals 0.2, scale.y plus equals 0.2, and it'll scale it up thusly, right? As we talked about in lesson 7, the scale variable has two subvariables. Hold on. This thing's going to be moving. It's so distracting. Has two subvariables to it, x and y. This is because scale is a vector 2, which stands for two-dimensional vector. Which stands for two-dimensional vector. All right. A vector 2 represents 2D coordinates. All right. I'm telling you, this is really distracting. Me. Maybe not you, but I'm totally me. What are vectors? A vector in physics is a quantity with magnitude and direction. For example, a force applied to some object, the velocity, speed, and direction of a character, and so on, right? We often represent this quantity with an arrow. In Godot, 2D vectors are a common value type. Are a common value type named vector2. Unlike plain numbers, they store two decimal numbers, one for the x coordinate and one for the y coordinate. All right, so we can see right here, this has a max of negative 60 in this direction, 160 in this direction, 160 in that one too. Same here and same here. And so the x is this one and the y is this one. You can see them change like this, especially if we just go like that. This is the x, that's the y. Anyway, whatever. Let's go to the next thing. So far, we've come across two variables in the course which are vectors. Which are they? Health? No. Scale? Yes. Position? Yes. Speed? No. Submit it? All right. So both scale and position have x and y subvariables. So Godot uses a vector 2 to store their values. All right. Vectors are great for... This is going to be following us around too. Vectors are great for games. Vectors are essential in video games. All right. Very true. They allow us to represent a character's movement, speed, and direction, calculate the distance to a target, and more with little code. All right. Take this turtle AI below. Yeah, the one that's chasing the cursor. Right. We've probably seen games where enemies move like this. This is done with just 7 lines of pure vector calculation code. The code's a bit too difficult for now. Honestly, when I see this, I feel like, remember, I was just watching an Undertale playthrough yesterday. Remember that like sheep lady at the beginning, the sheep lady that would always hold the little kid's hand? The code's a bit too difficult for now. So they'll spare us the details, but this turtle gives us a glimpse of what 2D vectors can do for us and our game projects. Yeah. Once we get into AI, we're going to be doing stuff like that, but not today. We scale the robot again, this time by adding it to it directly using a vector 2. The following code has the same effect as the previous example, right? So remember up here, we have the scale.x, scale.y. So down here now, we've got scale plus equals vector 2, and this is the x and this is the y. Is that fewer characters? I don't know. Anyway, so that's what we're going to be doing from here on out is vector 2. And then when we level up, same thing. All right, so notice how we use parentheses and 2 arguments inside the parentheses, just like other function calls. There should be a parenthesis there, but I'm sure there is one. That's why it works. We call this a constructor function call. We can think of it as a special kind of function that creates a particular type of value. All right. The code vector2 0.2 0.2 constructs a new vector2 value with its x set to 0.2 and its y set to 0.2 respectively. Anyway. let's get back to it. Using vectors to change the position. We can add we can add and subtract vectors to position because it's a vector. If we wanted to move our robot to a new relative position, we would add a vector 2 to its position. Okay. So we can add and subtract it, right? So position plus equals vector 2, 20, and then I'm sure the next one's 20 also. Move, it moves 20, and oh yeah, plus moves down. I mean, yeah, positive moves down. So yeah, 20 this way and 20 this way. All right, cool. See ya. Oh. Interesting. Anyway, how would we move the robot 50 pixels to the left? We would do position.x minus equals, no. Just position, just like here, this one here. Position minus equals vector 2, 50, 0. Submit it. How about we check it, then submit it? All right, cool. So we're right. Position minus equals vector 2, 50, 0 subtracts 50 from the subvariable x and 0 from y. Position.x minus equals vector 2, 50, 0 tries to subtract a 2D vector from the subvariable x, but subvariable x is actually a decimal number, all right? So it's trying to subtract this thing, but it's actually just the number, right? And so how are you going to subtract, how are you going to subtract the letter B from 530? You know, you can't do it. It's two different things. Anyway, the value types are incompatible. If we try to do this, we will get an error. True. So in the next few practices, we'll use vectors to change scale and position values. Okay. So we got the practices here. Increasing scale using vectors. We're going to visually show our robot has gained in strength by increasing its size every time it levels up. Nothing could go wrong. Okay, we'll see. Anyway, so the goals on this one is add a line of code to the level up function to increase the scale of the robot by vector 2, 0.2, 0.2 every time it levels up. All right. So we're going to increase scale plus equals, and then we'll do vector 2, vector 2. Hold on. Okay. Vector 2, 0.2, comma, 0.2. And that should take care of it. Let's run it. All right, got a little bit bigger. Twice, okay. 1, 2 right there. Continue. And now we're on to resetting size and position using vectors, okay. So the robot's level has increased by a lot. Yeah, it sure has. So it has, and so has its size, okay? Let's fix this by resetting the robot's scale and position values. We're going to create a function named resetRobot that sets the scale and position of the robot. The x and y subvariables of the robot's scale need to be 1.0. The robot's position needs to be vector 2, 0, 0. As in the previous practice, we're going to make sure to use vectors when dealing with scale and position. Of course, it's easier, right? So what are we calling this? resetRobot. So func resetRobot. All right. And for this one, it's not taking any parameters. So we'll come down here and we will say scale now equals vector 2. And we are going to put 1.0, 1.0, right? 1.0, comma, 1.0, all right? And then we'll do the second one, the position equals vector 2. And we are going to put 0, 0 on this one, 0, comma, 0. That's not a 0. 0 like thus, all right? So let's run it, see if this thing shrinks. And it does. Looks good, looks good. Oh, he waved to us. Okay. And continue. All right. So that's the end of that one. So now we're on to introduction to while loops. We haven't done while loops yet. Okay. Introduction to while loops. And we'll see you next time.